think you don't have a job with it.
Yo, think about it.
Bless your heart, Dustin.
I know you're sad for this being the last lesson, so a little moment of silence. I know.
Yeah.
No tears. I got plenty of tissues.
We're halfway through.
Our final lesson. Here it is. College algebra. 9.4. Systems of nonlinear equations with two variables. So we're going to solve them by substitution method, addition method, and then a little bit of application to finish it out. Okay? The good news is, if you mastered the linear system stuff, then we're just using the same stuff in nonlinears. Okay? That's not good. Let's try. Flash. Okay. Flash.
It looks like a shadow. Let's go.
Now you just get 2 blushes, that's it. No more. Okay, in this lesson, we're going to have a nonlinear system of equations.
Curse you.
Is a system
First two
in which one or more equations is nonlinear. So they both don't have to be. As long as one of them is, we classify as nonlinear. So example, you got negative x plus 7y equals 50, x squared plus y squared equals 100. Okay, so the first one is a linear equation, the second one would be a circle, which would be nonlinear. Okay? Or you can have both of them. So 2x squared plus y squared equals 17, x squared plus 2y squared equals 22. So that is an example of both of them not being linear. You just got 2 circles. Okay? Now, a solution to a non-linear system of equations and 2 variables, man, that's wordy, is an ordered pair with real valued coordinates. Okay, so we're not doing anything complex. So real value coordinates that satisfies each equation in the system. So it's not, acceptable that only one of those solutions works for one of the equations. It has to work for both. So we're going to get some really cool looking scenarios here. I'm just going to go ahead and draw 3 little graphs. So if we're doing nonlinear stuff, what are some graphical things that we're going to encounter? Okay. Well, we can encounter a circle with a line. And if something like that happens, we could have 2 solutions. I mean, maybe the line doesn't hit the circle at all. That'd be 0 solutions, right? Or it's tangent to the circle. That's 1 solution. But again, just shown graphically that one of the things we could have. Another one could be 2 circles. Okay. Let's see if I can try and draw it. So you have 2 circles that could collide. You could have, well, 4 solutions. And let's say you had a circle down here, parabola up here. So that would be a no solution. The importance of the graph, though, when you're solving a nonlinear system, look at the first example I wrote up there. I have a line and a circle. So in my mind, I want to make sure that I understand what I could be getting as an answer. I could be getting 1, 2, or no solutions, okay? If you solve that and get 3 answers, then you know you did something incorrectly. So the graph just kind of gives us that indication that, like, am I on the right track? Should I be getting that many solutions? And so forth. Okay. Example. Solve the system by using substitution method. have a line, and then that'd be a parabola, right? U-shaped curve. So picturing not that exact graph in your head, but just think of like a normal line and a parabola. So that means that that line could go through the parabola twice. So I could have two answers. It could just hit it once, so one answer, or maybe not at all. So I'm looking for 2, 1, or 0 solutions for this guy. Okay? Now for substitution method, just like with the linear stuff, look at an equation and solve for a variable, sub it into the other one. Well, we kind of lucked out here. Isn't one of my equations already solved for a variable? I think it is, huh? So looking up here, I can see that equation 1's already solved for y. So let's just use it, okay? So I'm gonna just put here, I'm gonna sub equation 1 into equation 2. Now again, if it wasn't solved for something, you'd have to try and do that. Okay, so let's take a look at this. So we're gonna have 2x squared minus 14 negative x plus 7 equals 0. Okay. Yeah, I do have 2 x's there, don't I?
Yeah.
Don't I? I don't know what I did there. Thank you. Yeah, looking at that, I'm like, that's an issue. That's a big issue, actually. Oh, hold on, guys. I know what I did wrong. Speed kills. Speed really kills. I wrote down the next step. Hold on. I'll pause for your moans. X plus y equals 7, x squared plus y squared equals 49. I wrote the next step underneath as the original system. Sorry about that. That's the original equations. Well, if this is the last lesson, we gotta make it memorable, my gosh. Okay. So, let's go ahead. I'm gonna solve equation 1 for y, then sub into equation 2. I'm not here. Hello? No. We should be running late, but she's not here right now. No. Sure. Thanks. Anyway, so yeah, I'm going to solve for y, sub it into equation 2. Okay. So y is equal to negative x plus 7. So now this becomes x squared plus negative x plus 7 squared equals 49. Okay, that looks a lot better. Me meshing steps together was not good. Helps if you read correctly too. Now looking at this, I have nothing but x squareds eventually, which is good, okay? Because again, if you're making a substitution, you still have two variables. Maybe you did something wrong there. So this is going to be x squared. Now this guy, I'm going to go ahead and just use a little shortcut. So negative x squared will just be x squared. Multiply these together, you get negative 7x, double it, minus 14x. And then square this one, which you get 49 equals 49. But if you need to, you certainly could expand this. And when I go off to the side and actually show the FOIL method to break that binomial down, please do so. Well, some good things are happening. 49s are going to cancel out, right? So I'm left with 2x squared minus 14x equals 0. Now that's a very simple quadratic to solve. I can factor a GCF out of those terms and then use the zero product property. So I can factor a 2 out and an x. is I get x minus 7, okay, equals 0. I have space, I'm going to put it up here now. So we get 2x equals 0. We also get x minus 7 equals 0. So we get 0 or 7. So 2x comes. Okay, what to do next? Well, that is just the x coordinates of where these guys collide, okay? So if that's the case, then I gotta plug it into any equation to find the y coordinates where those intersection points are gonna be located. And it looks like equation 1 would be the easiest to plug them into. So I'll put here, I'm gonna sub into equation 1 to find y coordinates. Okay. So let's see, the first one would just be 0 plus y equals 7. Well, it's 7. 0 is very nice to work with. So we get 0, 7. Over here, I'll plug 7 into there. So it'd be 7 plus y equals 7. Y 0. So we get 7, 0. So we'll put down here solution set. 0, 7, 7, 0. There's my final answer. Okay. Any questions on that? Besides me goofing up at the very beginning. All right, perfect. Moving on. Let's try this example. Solve the system using the substitution method. Now again, think about the visual and how many answers I could have. So the first was a circle, and the other guy's a square root, which looks something like this. So either you could have a no solution problem, or maybe it's over here, and if it is over here, that's going to hit twice, so it could have 2 answers. Okay? So just the visual is going to help me just to identify if I'm on the right track or not. Now y is already solved for us, so why don't we just go ahead and use it, okay? Typically with these problems, if you have something with an exponent of 2 or even greater than that, whatever's linear, you want to substitute it into there, okay? I would not solve this for like x and then plug it into here and then you have y squareds and stuff like that. Just make it easier on yourself by just, working with the linear equation for a variable you want to solve for. So here we go. Sub equation 2 into equation 1. So x minus 1 squared plus square root of x minus 3 quantity squared equals 4. Expanding some things out, so the x minus 1 squared, again, just kind of shortcut it here. So we square the first term, multiply these together and double it, so minus 2x, square the last term. The square root and the power cancels out. I get x minus 3 equals 4. Now that looks more like familiar territory. We have a quadratic there, and we have many methods for solving it. Let's combine some terms first. So negative 2x and x, this will be negative x. 1 and a negative 3 would give me a minus 2. Okay? And then let's just go ahead and subtract the 4 over, so we set it equal to 0. X squared minus x minus 6 equals 0. So far, so good. Okay. I'm going to factor it. It is factorable. Usually when you go through methods like how do you want to solve the quadratic, factoring is always the easiest to start with. So factors of negative 6 that give me a negative 1 would be negative 3 and a positive 2 for that guy. Well, set them both equal to 0, I get x to be 3 and this x to be negative 2. Well, that's great, but I already know immediately one of them is not going to be good. Which one is it?
-2.
Yep. Why is that the case?
When you put it in square root, you get a negative.
Yeah. So this is only going to hit the graph, what, once? It's going to intersect only once. So this one here, okay, so this will just be undefined. Well, not undefined, I should put, it gives me an imaginary. So it's not going to be a real value. So the 3 is still good. So let's go ahead and plug 3. I'm just going to plug it into the second equation because that's going to be the easiest to work with. So we get y equals the square root of 3 minus 3. So that's just 0, and square root of 0 is 0. There we go. So only one solution. So this only hits at one spot. Okay, so maybe it was like somewhere here that it was hitting. So my solution set is going to be 3, 0. That's my final answer there. So just a couple things you got to keep track of when you're solving a system. Not only you want to keep track of how many possible solutions you could have, but you also want to see if some of your solutions doesn't work for one of the equations. So with a square root, we did have a little restriction there. Any questions on substitution then? All right, let's do addition, or what we call elimination method. Okay, example. Solve the system by using the addition method, which I'll put in parentheses because we call that the elimination method. All right. Now looking at that system, we have 2 circles. So we could have 4 solutions, huh? Kind of like what I just drew before I erased all that stuff. Just keep that in mind. If we do end up getting 4 answers, there's nothing wrong with that. Okay. Now, elimination method. Don't worry about the exponents for right now. If that was just a 2x plus y equals 11 and an x plus y equals 6, and I wanted to eliminate something, well, immediately I'm looking at the y's, and I could, multiply one of these equations by -1 and just add them, and the y's are gone, right? So that's what I'm going to do. Now, people in the past said, well, can you just subtract them? Do you have to go through that whole process? You can subtract. I'm not going to stop you. The only reason why I don't like subtraction, and the reason why most textbooks don't, lead into that, is for the simple fact that there's a lot of negative errors that could occur. Now, in this case, it's not as bad, but depending on the system, it could get tricky. So I'm just going to multiply, equation 1 by -1. Then add. So this is now going to be -2x squared minus y squared equals -11. Here's equation 2, which I didn't change nothing. Well, let's see what we get. So this is going to give me a -x squared. Y's are canceled. Over here, we're going to get a -5. Now I just solve for x. We'll divide both sides by a negative. So I get x squared equals 5. Then take the square root. Now, with square roots, we know that there's a positive and negative answer. So there's 2 answers for that one. Okay, positive square root of 5 and negative square root of 5. And it's okay, unlike the other ones, they came out to be nice integer answers. It's okay to have something that doesn't work out to be that way. So I have 2 answers here. What I'm going to do is plug that into any equation I'd like. I think equation 2 is easy to work with, right? So let's put a little note here. Now, plug both into either equation, your choice. Okay, I'm going to choose equation 2. So here we go. Let's start, and I'm just going to, just to make it easier for me, let's just notate what I'm using here. So I'm going to say x equals square root of 5. I'm going to go ahead and plug it into here. So let's see, that's going to be square root of 5 squared plus y squared equals 6. Well, square root goes away. So it's one of those things where when you first look at it, you're like, is that going to be hard to work with? But it isn't. So 5 plus y squared equals 6. Okay, we'll subtract them. So y squared equals 1. Now we're taking the square root, so we know that there's going to be two components there. It could either be a positive one or a negative one. Now here's where you want to be as organized as possible. So let's think about something. I plugged in square root of 5 and got two y values, right? So that's 2 points I found right there. So my two solutions, just for when this is happening, is square root of 5, okay, and 1. And then it could be square root of 5, negative 1. Let me just box that out there for a moment. Okay. So far, so good with that? Now I'm not done yet because I didn't plug in the negative square root of 5. Okay. So let me just draw a line here. Put x is equal to negative square root of 5. And I'm just going to go through the same process. Now, one thing to note, is that negative square root of 5 going to really make a difference? Am I going to get the same y values? I am, right? Okay. Because if I square this guy, well, doesn't that just become positive again? So you're going to get 5 plus y squared equals 6. So you're going to get the same answer here. You're going to get y to be plus or minus 1. Okay? And that can happen, depending on what your system has in terms of equations. You might get the same output values, but for two different input values. So my solutions for this guy, negative square root of 5 with 1, negative square root of 5 with negative 1. I am out of space, but I'm going to go ahead and right at the very top, I have a little bit of whiteboard right there. So my solution set, okay, square root of 5, 1, square root of 5, negative 1, negative square root of 5, 1, negative square root of 5, negative 1. So there we go. Okay. All right. Questions on that? So there's a lot of things happening. Calculation-wise, it's not bad. It's just keeping track of everything. Okay? So the more organized you are, especially with rewriting some of this stuff, the less likely you make a mistake. Let's keep going. Okay. Let's do one more with this. However, spoilers, it's not going to work. So let's solve an inconsistent system. I guess it's technically not solving it because it can't be solved, but still, at least you have in your notes that if you need to look back at an example, like what happens or what do we do when it doesn't work out? Alrighty. Now, looking at the prior example, again, I'm going to eliminate a variable, and it looks like x squared would be the easiest to eliminate, right? So what I'm going to do, I'm going to multiply equation 1 by negative 1, then add them together. So that's my goal. this is now going to be negative x squared plus 5y squared equals 1, x squared plus y squared equals 4. Okay. Oh, actually, negative 1, huh? And negative 5. Yeah, man, I just negated the first one and figured, forget it. The rest of them were good. Thank you. X squareds are gone. On this side, I get negative 4y squared, and I get equals 3. Well, this isn't looking too promising. And here's why. You get y squared equals negative 3 over 4. Now you're taking the square root. Well, square root of a negative, now you have i's. Okay? So I just pulled it out in front, but yeah, not good. So therefore, no solution. These circles don't intersect at all. Okay? So we're going to say the solution set is just empty brackets. And if you want to, why not? Let's do this. Let's put underneath here. What this means is the circles do not intersect. So we can put that little detail graphically, like what that means. Okay. So we covered substitution and elimination. Any questions on those two methods? All right, guys are golden. So let's try an application problem out. Let's finish it. And well, let's see if I can fit it on this board. If a right triangle has an area of 180 square centimeters and a hypotenuse of 41 centimeters, find the length of the two legs. See, one sentence application problem, looks harmless. So with application problems, I know people still kind of have some issues with setting things up, and I can see why. Okay, but if we're talking about area and hypotenuse, let's think about area for a moment. Okay, so area is half your base times your height, right? Okay, so we're probably going to use this guy. Now, talking about hypotenuse, and it's a right triangle. Is there a theorem that I can use with right triangles?
Yes.
Yeah. What's that guy that created it? We'll get there. We're going to substitute some variables in there. But it's what? Pythagorean theorem, right? So let me put that down. So that's a squared plus b squared. Oops. That is definitely not what I meant to write. Okay. So I have at least two equations that could be related to this problem. So that's what you want to do. Just write down some basic facts. Now, I don't know the lengths, and that sounds like variables to me. So let's let x be, well, let's just say one leg of the triangle. And then we're going to let y, well, be the other leg of the triangle. Okay? All right, so far so good. Cool. Now, the hypotenuse is 41, and the area is 180. Let's use that information with our new variables and see if we can't recreate these equations with that information. Let's start with the area one. So the area is 180. So that's going to be a half x and y. That's our two legs. And then for the Pythagorean theorem one, well, that's going to be x squared plus y squared equals 41 squared. Let me just box those out. So those are the two equations we're going to use to solve for the lengths. Questions? All right, cool. Let's do it. Okay, so what I'm going to do first is clean this up a little bit. So if I'm multiplying this side by a half, can I just multiply both sides by 2 to get rid of it, right? So this is just going to be 360 equals xy. So that's just me simplifying the first equation. The second equation, I'm going to simplify the 41 squared. So I'm going to do x squared plus y squared equals 1,681. Okay. So that's just my first step. Why not clean this up a little bit? Now, this looks like what we did at the very beginning. We have a linear and, well, a nonlinear one. So the substitution method would be perfect for it. So I'm going to take this guy, solve for any variable I like, and plug it into this guy and solve for that variable. Okay? Just like we did with the first example. And it's your choice on which variable you want to do. For me, I just chose to solve for y. So when I plug it into here, I get x's, and we're so used to seeing x's, so why not we just continue that trend? So I'm going to solve equation 1 for y, then sub into equation dos. Okay? So let's see what that looks like. So I have here y equals 360 over x. Let me go ahead and substitute that into the second equation. So we get x squared plus 360 over x quantity squared equals 1681. Okay. Now, squaring this guy, the number is going to get a little bit larger, but we'll handle it. Okay, so here we go. We get x squared plus 129,600 over x squared equals 1681. Again, don't be scared by the large value. It's okay. Now, here's the deal. That doesn't quite help me because I have an x squared on the bottom, right? I don't like that. So what I could do is I can multiply everything by an x squared. That'll eliminate this fraction. It will make that to the 4th power. We'll handle that. But at least this will be gone. Okay? So underneath here, I'm going to put here, I'm going to multiply everything by x squared. Okay, that'll help me get rid of the fraction. So here's what we get. We get x to the 4th plus 129,600 equals 16,000, or not 16, 1,681 x squared. Okay? I think it's one of those things where, like, I do it too. When I'm solving things and I'm getting large values, I do question myself a little bit. But stick with the whole problem, okay? Wait to the very end and then decide if you're on the right track or not. Like if you get some answers that don't look quite correct. I'm going to set this equal to 0. So we get x to the 4th minus 1681 x squared plus 129,600 equals 0. Okay. I'm out of space. Let's go over here. I'm just going to rewrite that because, again, that's all the way over there. Now, solving that. Again, I like to factor, and I mess with this a little bit. So the 1681, I could break that apart to 2 perfect square numbers. I could break it apart into 1681. And believe it or not, if you multiply those together, you do get this guy. So that's what I'm going to do. I'm going to factor this. But if you didn't see that, you can use quadratic formula. Okay. You can also use, well, maybe not well, you could use quadratic formula. You have to use U substitution. And same thing with, if you want to do like complete the square, you have to do a little U substitution there as well. But this one does factor. Okay. So we get x squared minus 1600. And then x squared minus 81 equals 0. Okay? So again, I mean, when I was looking at this, I knew these two perfect squares existed inside of it. So I used that to see if I multiply them, do I get that value? And it did. I lucked out. But if you didn't, like I said, maybe a little u substitution can help you with that. So we get x squared equals 1600. Okay, so x is just plus or minus 40. On the other side, we get x squared equals 81. So x is plus or minus 9. Okay, well, we got two answers, huh? For both of them. So now we gotta, what, test these out and see what's gonna work for this? Now here's the deal. We're talking about the lengths of two legs. So I can get rid of two answers quickly, huh? The negatives, gone. So all I'm gonna be concerned with is 40 and 9. Okay, does that make sense? So again, looking at the context of the problem, I'm not gonna worry about the negatives. Now let's substitute them. So when x is 40, I can plug it back into one of the originals. Okay, it doesn't matter which one. I'm gonna plug it back into the first one, is what I'm gonna do. So we're gonna get 360 equals 40 times y. So we get y to be 9. Again, I'll plug 9 into the first one as well. So we get 360 equals, let's see, that's 9 times y. And hey, we get 40. So no matter what are your two legs gonna be? 40 and 9, right? It didn't matter. That happens sometimes, okay? So, and you might encounter it when you practice this today and tomorrow, but if you plug it back in, nothing changes, that's okay. Now, here's what you could do. If they tell you specifically, like maybe this leg is a little bit longer, then you'd probably have that leg to be 40 first, right? So again, if the problem tells you a little bit more details, you can be more specific. Especially if you have like a rectangle, like which one should be which. But in this case, didn't matter. Okay, so our solution for the two legs are 9 centimeters and 40 centimeters long. There we go. By the way, I don't want to panic you. I wanted to give you an example where you had like something different than a quadratic, okay? Most of the time you do get quadratics where you can factor them normally, but I at least want to give you one example where it wasn't a quadratic, and how do you work with that? Alrighty, hey, you made it. One semester of college algebra under your belt. Any questions? You guys are awesome.